All right, this is about different types of edges. So you can have a graph and if there are more than one connections, if there's more than one edge, it's called having multiple edges. Okay. A loop is an edge that goes back to its own vertex. This would be an example of a graph that is not connected. Because I can't get from each vertex to every other vertex. I can't get from here to here, and I can't get from here to either of those, okay? So if I had a similar graph, so I'll draw my multiple edges here, and I'll draw my loop here, and if I had one more edge, now this is a connected graph. A complete graph, so I'll use those same three vertices, is where every possible edge is drawn in, okay? There aren't going to be any loops, there aren't going to be any multiple edges, but every vertex is connected to every other vertex. So this is an example of what a complete graph looks like with three vertices. If I have four vertices, a complete graph would look like this. They're all going to have three edges leaving each vertex. So this is another example of a complete graph. An equivalent graph is a graph that has the same number of vertices and has the same edges but just looks different. So if I didn't change even where my vertices are, and you can move the vertices around, okay? But these two are connected, I'm going to draw that edge out here. It doesn't matter that it's not a straight line. Edges don't have to be straight lines. I've been drawing them in straight lines because it's the shortest and easiest way to do it. But those two are still connected, okay? I can take these two edges and I can connect them out here. And then I just have these same four. The graph obviously looks different, but they all have three edges that leave each vertex, and it's still a connected graph. It's still a complete graph, okay? So these two would be an example of equivalent.